In this section, 6.3, we're going to talk about applications of linear equations for one variables. So in this section, you're going to learn how to solve application problems involving linear equations. In solving application problems, typically we have to translate an expression into a numerical values or variables. So for example, here are some phrases: 6 more than a number, right? So that's x plus 6. A number increased by 3, x plus 3. 4 less than a number, x minus 4. A number decreased by 9, x minus 9. Twice a number, 2x. 4 times a number, 4x. Some additional expressions that are often used: 3 decreased by a number, 3 minus x. The difference between a number and 5, x minus 5. 4 less than 3 times a number, 3x minus 4. 10 more than twice a number, 2x plus 10. The sum of 5 times a number and 3, 5x plus 3. 8 times a number decreased by 7, so it's 8x minus 7. 6 more than a number is 10, so it's x plus 6 is equal to 10. A few more expressions. 5 less than a number is 20. So now we have an actual equation here. 2x minus 6 is equal to 12. This is twice a number decreased by 6 is 12. Notice the is phrase is always the equal phrase. Right? Is always equal. And finally, a number decreased by 13 is 6 times a number. So here we have an equation of this sort. So to solve a word problem involving an equation, you don't always do all of these things, but you do some of them. First of all, you have to read the problem carefully. And it's recommended to read it more than once. And usually I highlight the most important parts of the problem. Okay? Make sure you understand it. If possible, draw a sketch. Sometimes drawing a sketch, especially geometric problems, helps visualize the problem. And also write out the equation strategy. Sometimes when we're talking about a type of problem, for example, a money problem or interest, we have a formula. Interest is equal to the principal times the rate times the time. So we write that strategy out if we see a problem similar to that. Then we say determine which quantity you're being asked to find. Choose a letter to represent this unknown quantity. Write down exactly what this letter represents. So the idea here is choose a letter, right? So now we want to always, with a word problem, we're going to end up writing a problem as an equation typically. And then we're going to solve the equation for the unknown quantity. And then answer the question or the questions asked. Check the solution. Check the solution. That's the final thing to do. And if it doesn't work out, then we have to go back to the drawing board. So in our first problem, we're looking at a house cleaning service. A professional house cleaning service charges a base fee of $20 plus $32.50 per hour to clean the Monez's house. If the Monez's total bill for the house cleaning service from this company is $117.50 before taxes, how many hours did it take to clean their house? So I did highlight the plus key, the plus word in this problem. That's a very important one. And the per hour. We look at the per hour stuff, right? So we immediately say to ourselves, the base fee is 20 plus 32.50 times a variable. So our strategy is going to be 20 plus 32.50 times some number of hours, right? So I write that down. And in this case, it's going to equal 1750, right? So here's our solution. We let n equal the number of hours. So 32.50 n is the cost for cleaning n hours, and we have 32.50 per hour, right? So our strategy, here's our strategy, the base charge plus the hourly charge equals the total bill. That's what we read from the problem initially. So we write it out. Here's 20 plus 32 times n is equal to $117.50. So that we have to solve for n. So as you can see, we have our initial equation. And now we subtract 20 from both sides of the equation because we're going to isolate n on one side of the equation. So when we do that, when we subtract 20 from both sides of the equation, we get 32.50 times n is equal to $97.50. Now we're going to divide both sides of the equation by 32.50. Why? Because we're going to try to isolate n. When we do, we get n on one side, and when we do the operation, 32 into 97.50, we get 3. So it took 3 hours to clean the house. Mark IV Construction Company purchased 100 acres of land to be split into 3 parcels of land on which to build houses. One parcel of land will be 3 times as large as each of the other 2. How many acres of land will each parcel contain? Well, one of the things we want to look at is that each parcel, let x equal a parcel, right? And so we have 3 parcels of land, but one of those parcels of land is, this is size x, this is size x, this is size 3x, right? It's 3 times as large as each of the other 2. Okay? So there's my picture. So now I've drawn out my picture, and we know that the total area has to equal 100 acres. So now we move on to the next part of our solution. So we let x equals the number of acres in first parcel, x equals the number of acres in the second parcel, 3x is the number of acres in the third parcel. So x plus 3x equals the total amount of land, and so we end up with 5x is equal to 100, and now x is 20 acres per parcel, right? So the two parcels will contain 20 acres each, and the third parcel will contain 60 acres, since it's 3 times as much. So here's our example 3. It's a dimension exercise. Whenever we see this idea of rectangular region, for example, now we know the strategy. We know that we're dealing with a rectangle that has either area or perimeter that we're going to be dealing with. That gives us our first clue. So, Dr. Christine, a vegetarian, she may be a vegetarian, but she's also a veterinarian, wants to fence in a large rectangular region in the yard behind her office for exercising dogs that are boarded overnight. She has 130 feet of fencing to use for the perimeter of the region. What should the dimensions of the region be if she wants the length to be 15 feet greater than the width? So in our picture we can have W, and now we can have W plus 15, right? And now we also know about perimeter. In a rectangle setting, it's twice the length plus twice the width. So those are our key areas of strategy for solving this problem. Now we'll go to the actual solution. Well, here's our picture that we drew in the last particular case. And we have our strategy, which is the perimeter is equal to 2L plus 2W. P is the perimeter, L is the length, and W is the width. We let W equals width, the length is W plus 15, and the perimeter is 130 feet. Somehow or another I accidentally put 300 there, but that is incorrect. Now, we plug in the numbers for our perimeter. So we had 130 is equal to 2 times W plus 15, which is our length, and then we had 2W, right? So now we distribute the 2. We get 130 is equal to 2W plus 30 when we multiply the 2 times 15 plus 2W. Well, now the W's add together. We get 4W. We get 130 is equal to 4W plus 30. And now we subtract 30 from both sides of the equation, and we get the following. 100 is equal to 4W. And finally, we divide 4 on each side of the equation, and we get 25 is equal to W. So essentially, the width of the region is 45 or 25 feet, and the length of the region is 40 feet. So Kim Stappenbach is selling her homemade jewelry at a craft show. Determine the cost of the necklace before tax if the total cost of the necklace, including an 8% sales tax, is to be $34.56. So here our strategy, of course, the type of problem we have is money. But we have that the total cost is equal to the price of her jewelry plus an 8% tax. So it's going to be the tax times the price. That's how we calculate sales tax, is the tax times the price, plus the price is equal to the total cost. So we're going to use that strategy in solving our problem in the next section here. So we let x equal the total cost of the necklace before tax, and we have 0.08x, which is 8% of the cost of the necklace, which is the cost of the necklace before tax. This is the tax rate, actually, 0.08 times x. So the cost of the necklace before tax plus the tax on the necklace is equal to the total cost, right? That's what we said. So we have x plus 0.08x is equal to 34.56, right? When we add the x to the coefficient of x plus 0.8x, we get 1.8x is equal to 34.56. Now we divide both sides of the equation by 1.08 to isolate x, and we get x is equal to $32. So the cost of the necklace before tax is $32. This concludes our section on Chapter 6.3 for working application problems for linear equations. In the next chapters, we're going to talk about actually graphing linear equations and using those equations to plot lines.